Now moving forward, let's consider the next one, that is question number 7 from section B. The minimum value of alpha for which the equation 4 upon sine x plus 1 upon 1 minus sine x equals alpha has at least one solution in the interval 0 to pi by 2. So let's understand. We are talking about the minimum value. The minimum value for this expression, if we plan for, we can start it like this. Say I read it 2 upon sine x plus 2 upon sine x plus 1 upon 1 minus sine x divided by 3, arithmetic mean of 3 numbers. This is greater than equal to their harmonic mean. That means 3 upon, we can write sine x by 2 plus sine x by 2 plus 1 minus sine x by 1. Otherwise, we can also plan by simply finding its derivative using maximum minima approach, so that we can plan for the minimum value in the interval. That way we can do it. All right. Now moving forward, here we see that this value, that is say alpha, is greater than equal to 9. So what's the minimum value obtained? That is obtained as 9. So the value 9 that can be obtained here, and when you are getting this value, when you say that 2 by sine x is equal to, at 2 by sine x is equal to 1 upon 1 minus sine x. On cross multiplying, you obtain the value of sine x as 2 by 3, which is well within the given limit. So yes, the correct answer for this question is 9. I'm sure this is clear. Let's take up the next one. Let M be any 3 by 3 matrix with entries from the set 0, 1, 2. The maximum number of such matrices for which the sum of diagonal elements of M transpose M is 7. Now, when you talk about the diagonal element of M transpose M, obviously you can write this term as trace of M transpose M, and this is equal to summation j equals 1 to 3, summation I equals 1 to 3 aij square. When you multiply, you would be getting these terms. Obviously, these are the 9 ones, and this value is given to me as 7. Now, it is being taken from the entries 0, 1, 2, correct? Total elements we have here 9. All right. Out of these 9, if I say 7 are ones and 2 are zeros, so one possibility, 7 ones and 2 zeros. That means you can say 9 factorial by 7 factorial into 2 factorial, or simply you can say that out of 9 entries in that 3 by 3 matrix, where I have to put these 7 ones, I have chosen, at remaining places I will put 2's. So this is simply 9c7. So this gives you 9 into 8 upon 2, that is 36. Clear? Next, it is also possible that instead of saying all ones, there are certain 2's. Say 1, 2 is being taken. So square will become 4. You have still 3 entries for ones. So what I am saying, second possibility, 1, 2, 3 ones and remaining zeros. How many remaining? We have 4 entries so far, so 5 zeros. Now, we have to put these entries into 9 places. So how to put it? Simply arrangement is there. 9 factorial divided by 3 factorial into 5 factorial into 1 factorial, you can say. So this gives you 9 into 8 into 7 into 6 divided by 3 factorial, which is simply 6. So this is equal to 504. Now we need the sum of these two. So the required number of ways, sum of the two, that means therefore required ways, that is 540. So let's write this one as the final answer, 540. I'm sure this is clear. Let's move on to the next one, that is question number 9. limit n approaching to infinity, tan of summation r equals 1 to n, tan inverse 1 upon 1 plus r square. Let's try this question. Limit n approaching to infinity, tan summation r equals 1 to n. We can read this term as simply r plus 1 minus r divided by 1 plus r into r plus 1. So that gives you tan inverse r plus 1 minus tan inverse r. I'm sure this is clear. All right. When you put the limit 1 to n, you are getting it as tan of tan inverse n plus 1 minus tan inverse 1. Right? You can simplify it, and that gives you limit n approaching to infinity, tan of tan inverse. This gives you n plus 1 minus 1, that is n upon 1 plus n plus 1 into 1. Now, you can apply limit n approaching to infinity. So this gives you simply approaching to value as 1. So the final answer for this question is 1. I'm sure this is also clear. Let's move on to the question number 10. That is the last question of this section. Let three vectors a, b, c be such that c is coplanar with a and b. A dot c is given as 7, b is perpendicular to c, a vector and b vector are also given. Question is, find the value of this term. This means you need mod a square, mod b square, mod c square, a dot b, a dot c, b dot c. Clear? A is given, b is given, so mod a, mod b are there. Now, let's write down what is known to us. We can say mod of vector a, it is root 3, mod of vector b, it is root 5. Now, c is coplanar, so lambda times a vector plus mu times b vector, right? Also given to me, a dot c is 7. A dot c is 7. B dot c is 0. Now, a dot b can also be obtained because it is required later. So, a dot b, this is equal to, by taking dot product of the two, minus 2 plus 1, that is minus 1, right? What we are looking for now? Simply mod c. Now, we can see that a dot c is 7. So, here a is minus I plus j plus k and c is this one. So, when you take dot product with a, you are getting lambda mod a square plus mu a dot b is equal to a dot c. A dot c is 7. So, here you can write it as, since mod a is root 3, so this is 3 lambda minus mu is equal to 7. This is one more equation obtained. Next, when you go for b dot c is 0, right? So, taking dot product of b with c, what you will be getting? Lambda times a dot b, lambda times a dot b plus mu times mod b square is equal to 0. Now, going forward, we can put the values. A dot b is minus 1, so minus lambda plus 5 mu is equal to 0. This is equation say 1, this is equation say 2. Just solve 1 and 2 to get lambda and mu, and we obtain lambda as 5 by 2 and mu as half. So, yes, we are in a position to write c vector now. So, c vector is lambda a vector, that is 5a vector plus mu, that is simply b vector divided by 2. Put a vector and b vector to get c vector also. From there you can get mod c. So, yes, finally what we are looking for, 2 times mod a plus b plus c whole square, which is on expanding just mod a square plus mod b square and so on. Just put every value and get the answer as 75. So I'm sure this question is also clear. So let's write down the final result is 75. So this is from the paper of JEE Main, which was conducted on 24th February 2021 in the morning section. Thank you for watching the video.